All right, so we're here at the beginning. We're going to start out. First off, we need to talk about matter, right? So, matter is basically everything that we have, right? Anything that takes up space or has mass, or they got to have both, right? So, matter takes up space and has mass. Really, if we think about it, that's pretty much everything, right? We got water, we got air, we got anything solid, right? They always take up some amount of space and they all have mass. And so, really, we need to kind of break down our different types of matter, right? So, our first breakdown is whether or not we can separate it by physical means. So, if we can separate it by physical means, right, I can break it down by size, so I let the smaller things go through. If I can maybe separate it by looking at and looking at the interactions between particles, right? There's lots of different ways to physically separate something. But if we can't physically separate it and it always just stays the same, this is what's known as a pure substance. Okay? But if we are able to separate it by physical means, right? If we're able to separate it by a physical means, that means that we've got some sort of mixture. Okay? So then we have some further breakdowns, right? We have different types of pure substances. So our pure substances can either be separated by chemical means or not. Okay? So chemical means, right? That means that we're doing an actual chemical reaction. So sometimes if we try and take our compound and break it down into various parts to get through a chemical reaction, and we still don't get anything else, we still have that same piece, this is going to be an element. Okay? So elements cannot be separated by chemical means, right? But if we realize that we can actually break it down, right? We heat it enough that a chemical reaction occurs. If we maybe react it with with something else and we're able to strip something off, this would be called a compound. Okay? So our compounds and elements, the difference between them, they both are pure substances, but our elements and compounds, the compounds can be separated by chemical means. Elements cannot. Okay? So if we have a mixture, we have a breakdown for that as well. There are different types of mixtures. If it's the exact same all the way throughout, this is called a homogeneous mixture. And if it's different throughout, right? If it's maybe thicker on one side versus the other, if it's got some of one thing on one side, something else on the top, this would be a heterogeneous mixture. Okay? So I think in my mind it's kind of easiest to get some examples to really understand what these different pieces are. Okay? So if we had a heterogeneous mixture, maybe like oil and water, we know that the oil and the water, they're not really going to mix very well. They'll mix a little bit, but the oil's going to mostly stay sitting on top of the water. And so this would be a heterogeneous mixture. We could also think about maybe sand and water, right? Sand and water, again, the sand is going to stay, it's going to sink down to the bottom. The water itself will be mixed in with the sand, but it's not even all the way throughout. So our way to kind of symbolize this is to use a particle diagram. Particle diagrams are a visual way to symbolize our pieces of matter. Okay? So a particle diagram may be like this, where we've got circles on the bottom, and squares up on top. that's not even all the way throughout. This maybe would be our sand, this would be our water. Our water is kind of mixed in, so maybe there's one water molecule down there and one down here, but our mixture is not even all the way throughout, okay? So what we can show with our particle diagram is that this would be a heterogeneous mixture. Our homogeneous mixture, an example for this would maybe be something like our soda or our juice, where it's going to taste hopefully the exact same at the very beginning as it does at the end, right? So if we have juice, or maybe we have coffee, or maybe we have salt water, right? It's going to be the exact same all the way throughout. So when we start our juice at the beginning, it should be the exact same when we finish that juice at the end. So our particle diagram for this needs to symbolize that it's even, or it's the exact same all the way throughout. So for this, I'm going to use different colored circles. We've got dark circles and light circles. And what we can see is that each circle, right, our light circle sees a dark circle and two light circles. This one, we've got in between, all of them are going to be the same all the way throughout. Okay, so our particle diagram shows that our homogeneous mixture has the same composition all the way throughout. Alright, so what about compounds? Well, we actually know a lot of compounds. Compounds can be separated by chemical means. If they can be separated by chemical means, this would be something that has multiple elements in it. So something like water. Water, we know, is H2O. It's got hydrogen and it's got oxygen. So compounds, right, they can be separated by chemical means, and they're going to have multiple elements contained within them. So our particle diagram now needs to show that. So we're again going to have different pieces or different symbols to symbolize our different elements, but to show that they're chemically bound, right? If they're chemically bound, it's going to have all of the circles are going to be touching. So this would be something like water right there. We've got a big circle maybe to symbolize our oxygen, and a smaller circle that symbolizes our hydrogen. And you can see that we have different colors, right? Our dark color maybe symbolizes our hydrogen, the big circle would symbolize our oxygen. And what we can see is that this compound right here is chemically bound. So we wouldn't be able to separate it by physical means. We would have to separate it using a chemical reaction. Okay? And our last piece is our elements. Elements cannot be separated by chemical means. This is why our elements are on the periodic table. It's the periodic table of elements because we can't break down those pieces anymore. Okay? So this then would be like hydrogen or would be like oxygen. Okay? So we have a particle diagram that just doesn't have anything, right? It only has one type of circle contained within it. But there's a special piece with this. There are elements that are diatomic elements. So a diatomic element, I'm going to write it up here. A diatomic element has two atoms. Di means two atoms. But those atoms are the same type. So we could have, I'm going to give it one particle diagram up there, different particle diagram down here. It's chemically bound, right? They're chemically bound, but it's the same type of element. So you're not really going to be able to get a different element out of it, okay? So it's still an element, but it's a diatomic element, okay? And we'll talk about what those are.